Hello and welcome back. I hope you're all keeping well in these troubled times. Sorry not posted for a little while. Not really had anything to post and sort of life gets in the way. You know the score. So today on the bench we've got what is hopefully going to be eventually a Valve preamplifier. I'm going to use these enclosures that were originally, this is a power supply for a satellite receiver, and would accompany this, which had one of these McGubbins in there. As you can see, it's a really sort of nice board. I've no idea what it does. I presume it takes signals from a satellite dish, decodes them, and yeah, send them to a television or something like that, or some sort of monitor. So that went in there like that. Let's move that a minute. And this was the power supply. So in there was a big toroid, a small power supply PCB, and also there's various other nice sort of parts, a few fuse holders, a boggin or a cinch 4-way connector, power switch, and what have you. This build is going to have to be done on the cheap sort of thing, using the parts that I've already got. So as mentioned, we've got the enclosure, we've got a toroid. This is the one that came out of it, but I've already got a similar one that I've rewound to give us HT voltage and what have you. And then we've got a sort of adapter plate which will sit in there. If I tilt that up you can see it a bit better, hopefully. Yep. So I've got an adapter plate in there where I've just knocked up a bridge rectifier out of some avalanche diodes, 1000 volts. What else we got in there? We've got to have a heater supply as well. So this is just something I knocked up the other day. That's obviously got to go in there because it's going to be a DC heater. And a friend of mine, Joe Bogatek, who you may have mentioned him once or twice in the past, has built and sent me a couple of really nice output transformers. These are a couple of chokes I've got which we can use if necessary. I've already got some 220 microfarad EPCOS 400 volt capacitors. Joe also kindly sent me some more capacitors. This was his from his preamp power supply design, and so that will make up the power supply. As mentioned, I shall be using probably one of these connectors, so that should give us ground, HT. We've got to have a heater voltage, and we also need another voltage which I'll get onto in a second. So hopefully that should do the job. If not, then somewhere, I'll just put down somewhere, I have got a 6-way connector which I can't find just at this second. So that was a quick look at the power supply. For the actual preamplifier, which I could actually fit all in that one enclosure, but I'm going to use a separate one of, this separate enclosure, probably upside down, although that doesn't look too brilliant. But we're going to have I'm going to have to use this bank of RCA's inputs, which will fit somewhere on the back there. I'll probably have to, I'll take this PCB off, and that's got to be widened a bit. They will go on the back for inputs and maybe some outputs, because we don't need too many inputs and outputs. Then we'll have I've got this nice little ceramic wafer switch, 10-way, yeah, I think it's 10-way, which is more than enough for our purposes, which probably will sit somewhere at the back there. Well, hold on, let's get this round the right way. Yep, that shall sit at the back there. obviously they will go there, that sort of business. We want to try and keep all our leads as short as possible because we want to make this really quiet. We don't, you know, with a really low noise floor. Should also be using one of these cheap Chinese remote control potentiometers. That will sit there at the front there somewhere. So that's why we need something else to supply this, although I'm not sure. This runs off either 9 volts AC or 5 volts DC. So basically, I mean, we could use our DC heater supply regular. I mean, this has already got the regulator down, so in theory we could just put our DC supply in there and it will regulate blah blah blah. We're going to be using, I keep saying we, I keep thinking the Bleeding King or something. I am going to be using 6 CG7s, you can see that, new old stock valves. The 6 CG7 is essentially a 6 SN7 in a B or Novel or B9A bottle. It's sort of equivalent to an ECC 82, 12B87, that sort of thing. Dual triode, we're using those. So that's the hardware that we've got to go in there, or some of the hardware. From an aesthetic point of view, let's just say this is the top for the moment. I think that's going to look a bit daft with just a couple of valves sitting on there. They're going to look a bit lonely, aren't they? So yeah, I'm not quite sure aesthetically, from a sort of design point of view, whether that's a good idea. I mean, they would look more at home, wouldn't they, if they had a few sort of capacitors or something to keep them company. So that's something that I like to keep in mind on my builds. It's not just got to function well, it's got to look good as well. So that needs some thinking about. Okay, that's a quick look at the hardware, as it were, the enclosures, the capacitors and all that majiggins. This is the circuit that we're going to be using. This is called a constant current, hold on, where is it? CCDA, constant current draw amplifier. John Brodsky is the man who designed it, and I will put a link in the description where you can go and have a look at it. I won't go into the detail of why you want a constant current draw and all the rest of it. Let's just try and keep it simple. So on the input we've got our 100k potentiometer, which will be our remote control pot. I've got a decoupling cap there, just in case, you know, whoever decides to use it in the future, plug some sort of DC in. But it also, if we was to connect the wiper of that pot straight to this 1 meg resistor, this is a grid leak resistor, then potentially, because these are in parallel, the grid of the valve can be grounded, can be pulled down to ground. We don't really want that, so that decoupling capacitor does two things. It stops a DC source getting into the grid, which we don't want, because that will mean that the valve is biased incorrectly. So it offers a bit of protection, and it also keeps our DC operating conditions in good fettle. We've got a 430 ohm cathode resistor. I haven't got one of those, so I'll probably use something like a 330 ohm and 100 ohm in series to get that. There's no coupling capacitor, decoupling, AC decoupling. We want this gain stage to be low. The problem you got with a preamplifier is that you don't want it to, say, amplify a 500 millivolt signal, or in a lot of cases a line voltage is 1 volt RMS. We don't want that to come out as 20 volt RMS. We just don't need all that gain. Also, the more gain you got, the more noisy it's going to be. So by having no decoupling capacitor there, that'll keep the gain low. The 6 CG7, like an ECC82, 12B87, 6SS7 and all the rest of it, has a gain of 20. So yeah, when this is all done and dusted, it will probably have a gain of about 6, although don't quote me on that. We've got a 20k anode resistor, and this is our voltage gain stage. This is directly coupled to the other stage, which is configured as a cathode follower. You probably won't hear it. There's a dog, my neighbour's dog's barking. It's fucking neck ringing. Pardon my French. So this is configured as a cathode follower. Why do we want a cathode follower? Well, imagine that this is connected to our RCA output. You might have quite a long cable connecting this to our power amplifier. So this stage here wants to be able to drive the signal cleanly, meaning that we want a low output impedance. A cathode follower gives that. It's got a high input impedance, but it's also got a low output impedance. This is good. As you see here, we've got a diode. This is to protect the valve. When we first apply power, this cathode will be at 0 volts, same as the grid at 0 volts. But as the heaters of the valve warms up, more current will flow through these resistors and the voltage here will rise. What we don't want is a situation whereby the valve is biased hard on. It'll weaken the valve. So when we first start up, this diode is in forward biased mode. So there will be something like a 0.6 volt voltage or potential between the grid and the cathode. Once this warms up, once the valve warms up, the diode will be reverse biased and will be essentially switched out of the circuit. And then coming to the last bit, cathode follower, we've got this 430 ohm cathode resistor that biases the valve here at 102 volts. We've got 100 volts here on the anode, so basically this valve will be biased at -2 volts, or the grid will be. On the output we've got a 4 microfarad capacitor with a 1 meg resistor there. That's just so the valve sees a load. I'll go into the circuit in more detail in the next video. Right, to conclude, the power supply is going to be pretty simple, although this is only a professional design. So we've got this is the HT supply. We've just got a HT winding here, 212, 214 volts, fuse, bridge rectifier, capacitor, choke maybe, although I might just use an RCRC filter, 220 microfarad capacitor, resistor, and pretty much the same sort of thing. I'll go into more detail, a lot more detail, in the next video. The heater supply will also need some, we'll need a few minutes to cover that. My first thought was to do something very simple, pretty much like this, but without the choke, bridge rectifier, capacitor, heaters. But from what I've been reading and a few comments that Joe, who was mentioned earlier, have made, I need to look at the heater supply in a bit more detail. John Brodsky, in the manual, because he does PCBs for this CCDA amplifier, he uses a regulated power supply using a low dropout voltage regulator. In this build I wanted to try and keep things simple. I haven't got the money for a PCB, etc. And I wanted to try and keep this build simple, so that it's simple, quick, and bish bash bosh, done. Okay, I think that's all now. It's just a preliminary video, this one. Thank you very much for watching. Take care of yourselves. Ta-ra for now.